Hello, welcome. This is Hisabati Masterclass, and it's another day for our topic of integration. And today I have these two questions, A and B. So before we start them, let's see a simple concept. Now, in integration, if you have a rational function, so suppose you have a rational function such that the derivative of denominator equals to the function which is at the numerator, then directly the answer is natural log of denominator. So this is how we do it. Sometimes it may not be direct. You may have a function in the denominator, then constant times a derivative of denominator. But it's simple. Once you see that there is a constant times, so we know with the properties you can factor out a constant and then you remain with your derivative there and then your function, then you finalize by saying the answer is natural log of x. And this is what we have been doing when you have integral of 1 over x dx. It is direct because derivative of x is 1, the function at the numerator, then it's direct, that it's natural log of variable x plus c. So if you have a rational function and you find that if you differentiate the denominator, you get something which is in the numerator or a constant multiple of the derivative, then directly express your function in this form. You can decide to substitute a certain variable to your denominator, then you proceed. Now, for example, with our first question, the integral of 4 over 2x plus 3, you can see derivative of denominator is 2, but at the numerator we have 4. So it's like we can express in numerator, which is 4, as 2 times derivative of denominator, and then directly we'll have our answer. But we need to show the solution. So for our question, this one, 4 dx over 2x minus 3, someone may decide to say, okay, let me factor out a 2 and then I remain with the 2 inside over 2x minus 3. Now since the derivative of the denominator is 2 and we see that we have 2 at the part of numerator, then direct this, we expect it to end up with this kind of answer. But how do you reach that conclusion? So what we are going to do, so now this is the solution. So we say let u to be 2x minus 3. So we are going to change numerator to be a variable u, but we'll have to find derivative so that we get dx. So if you differentiate, we have 2 dx, which means dx is du over 2. So we can say now integral over 4 over 2x minus 3 dx is the same as integral of 4 over u times du over 2. So if we factor out 4 over 2 is 2. So if we take out 2, we'll have du over u. Now this one is standard. Integral of 1 over u du is known, is natural log of absolute u plus c. And we can substitute back now the value of u, which is 2x minus 3 plus c. So that one will be your final point. So that is how we do with the integrand which are in form of rational function. So before you proceed, if there are other methods, before you proceed, you have to check the derivative of denominator if it corresponds to that of the function which is at the numerator. So you can try part B and see the answer. I can give you the final answer for part B. We see that part B is dx over, I can write this as negative 7x plus 5 if we start with negative 7x, the way the question is written. So we can say that form. Now, according to the concept, we need negative 1 over 7, negative 7. So I'm just giving you the answer, then you try the solution. So there, if you write that form, you have not changed anything. So the derivative of the denominator is negative 7, and you see we have negative 7 at the numerator. So directly, the answer which we expect if you do the solutions will be this one. Now go and try your solution until you reach this point. So thank you very much. Again, this is a Hisabati Masterclass with your tutor, Mr. Kamima. Thank you. Don't forget to subscribe, to share, to comment, and like our videos. Ciao.